Chapter 1: The Brain's Remarkable Ability to Adapt. For much of the 20th century, the prevailing belief among scientists was that the adult brain was essentially set in stone by the time you reached early adulthood. According to that outdated view, once you passed your 20s, your neurons were thought to be locked into fixed patterns, with little ability to regenerate or adapt. This idea was reinforced by early autopsy studies that showed neuron loss with age, leading to the grim assumption that mental decline was both inevitable and irreversible. However, over the past few decades, advances in brain imaging, molecular biology, and cognitive neuroscience have completely overturned this notion. We now understand that the brain is not a static organ at all, it's more like a living, constantly evolving ecosystem. This ability to change is called neuroplasticity, and it's one of the most hopeful discoveries in the science of aging. Neuroplasticity is the brain's built-in capacity to reorganize itself by forming new neural connections, strengthening existing pathways, and even reassigning functions from damaged areas to healthier ones. It's what enables stroke survivors to relearn how to speak, allows a retiree to pick up painting for the first time, and helps someone in their 70s learn to play the piano with genuine skill. What's more, neuroplasticity doesn't shut down at 50, far from it. Your brain retains this ability throughout your entire life. The key difference after midlife is that you may need to actively stimulate and challenge your brain to keep it operating at peak adaptability. Think of neuroplasticity like a high-performance engine. If you run it regularly, it stays smooth and powerful. If you leave it idle, it can get rusty. Even small, intentional actions, such as learning a new language, traveling to unfamiliar places, or trying a different hobby, can wake up your brain and encourage it to lay down fresh neural pathways. This adaptability is not only essential for keeping your mind sharp but also plays a huge role in emotional resilience, problem solving, and maintaining independence as you age. Key takeaway: your brain is not frozen in time. It is a living, dynamic, self-renewing system, and every choice you make, from the challenges you embrace to the lifestyle you follow, influences how well it will serve you in the decades ahead. Chapter 2: Why Neuroplasticity Slows with Age, and Why That's Not the End of the Story. By the time we reach midlife and beyond, certain natural changes in brain chemistry, structure, and function can make learning and adaptation a bit more challenging. These shifts are part of the normal aging process, but they are not the end of the story, because they can be slowed, and in some cases, even reversed. Here are the main reasons neuroplasticity tends to slow after 50. Neurotransmitter decline. Neurotransmitters are the brain's chemical messengers, and they play a central role in learning, memory, and mood regulation. After midlife, levels of key neurotransmitters, such as dopamine, motivation and reward, acetylcholine, learning and memory, and serotonin, mood and emotional balance, can drop. This makes it harder to feel motivated, to retain new information, and to maintain emotional stability. Lower levels of growth factors. One of the most important proteins for brain health is BDNF, brain-derived neurotrophic factor. Think of BDNF as a kind of fertilizer for your neurons. It nourishes them, encourages the growth of new branches, dendrites, and strengthens synaptic connections. With age, BDNF production often decreases, slowing down the brain's ability to adapt and repair itself. Cumulative stress and inflammation. Chronic stress floods the brain with cortisol, a hormone that in excess can shrink the hippocampus, the brain's memory center. Meanwhile, low-grade, long-term inflammation can damage delicate neural structures and interfere with the brain's ability to form new connections. Structural changes in key brain areas. Imaging studies have shown that certain regions, such as the hippocampus and prefrontal cortex, tend to shrink with age. These areas are critical for memory, decision-making, and planning. The good news? This shrinkage can be slowed or even partially reversed through targeted lifestyle changes. While these factors are real, they do not mean your brain's fate is sealed. In fact, numerous studies show that even people in their 70s, 80s, and 90s can dramatically improve cognitive performance with the right stimulation. Regular exercise, mental challenges, social engagement, and nutrient-rich diets have all been shown to boost BDNF, protect neurons, and enhance neuroplasticity. Bottom line, age-related brain changes are not destiny. Your brain is still capable of growth, adaptation, and renewal, but it depends on how you use it. Chapter 3: The Science of Building New Neural Pathways. Every time you learn something new or approach a task in a fresh way, you're literally reshaping your brain's physical wiring. This is not a metaphor, it's a measurable, biological process. Here's what happens step by step. Stimulation. You expose yourself to a new challenge. Maybe you decide to learn salsa dancing, pick up woodworking, or memorize a poem. This unfamiliar activity triggers the activation of specific neurons related to that task. Neuronal activation. Those neurons begin firing electrical impulses, sending chemical signals, neurotransmitters, across synapses, the tiny gaps between nerve cells. The more often these neurons fire together, the stronger their connection becomes. Neuroscientists call this Hebbian learning, summarized as neurons that fire together, wire together. Synaptic strengthening. Repetition is key. The more consistently you practice, the more efficient the communication between those neurons becomes. Over time, the signal travels faster, and the effort required to perform the task decreases. This is why skills that once felt clumsy eventually become second nature. Structural change. With ongoing practice, the brain's structure physically changes. New dendritic branches grow, enhancing the network of connections. White matter, responsible for the speed of communication between brain regions, becomes more robust. MRI scans have shown increased density in areas of the brain associated with specific skills. For example, musicians often have larger auditory and motor regions. It's important to understand that intensity alone isn't enough. Consistency over time is what truly rewires the brain. A single burst of mental effort can spark change, but sustained engagement locks it in. That's why daily habits, even small ones, have such a powerful cumulative effect. Interestingly, novelty also plays a huge role. Trying something entirely new, as opposed to simply improving an existing skill, forces your brain to build fresh pathways from scratch, which supercharges neuroplasticity. That's why learning to play chess, speak Italian, or juggle at 65 can feel like rocket fuel for your mind. The takeaway: new neural pathways are built through repeated, focused engagement with challenging tasks. Your brain is designed to respond to your actions, and with deliberate practice, you can reshape it at any age. Chapter 4: The Role of Nutrition in Brain Plasticity. Your brain may weigh only about 3 pounds, roughly 2% of your body's total weight, but it's an energy-hungry organ, consuming close to 20% of your daily energy just to keep you thinking, feeling, and functioning. That means the type of fuel you give it can dramatically influence how well it forms new connections, repairs old ones, and protects itself from decline. Think of neuroplasticity like tending a garden. Without water, sunlight, and nutrient-rich soil, plants wither. In the same way, your brain needs the right mix of nutrients to create the biochemical environment in which new neural pathways can flourish. Key nutrients that power neuroplasticity. Omega-3 fatty acids. Found in fatty fish like salmon, sardines, and mackerel, as well as in flaxseed, chia seeds, and walnuts, omega-3s form the very building blocks of your brain cell membranes. They keep these membranes flexible, allowing for smooth communication between neurons. Higher omega-3 intake has been linked to better memory, improved mood, and even a reduced risk of cognitive decline. Antioxidants. Every second, your brain cells face damage from oxidative stress, unstable molecules called free radicals that can attack neurons. Blueberries, spinach, kale, and other colorful fruits and vegetables are loaded with antioxidants that neutralize these free radicals, keeping your brain's wiring intact. Antioxidants also help reduce the rusting effect that accelerates aging. Polyphenols. Found in green tea, dark chocolate, turmeric, and berries, polyphenols are plant-based compounds that fight inflammation and boost brain-derived neurotrophic factor, BDNF, your brain's growth hormone for neurons. Higher BDNF levels mean faster learning, better mood stability, and greater resilience against brain aging. High-quality protein. Neurotransmitters, the brain chemicals that carry messages, are built from amino acids, which come from protein. Sources like eggs, fish, poultry, beans, and lentils provide the raw materials for producing dopamine, serotonin, and acetylcholine, all essential for learning, memory, and focus. Slow-release carbohydrates. Your brain's primary energy source is glucose, but sugar spikes and crashes can leave you foggy and tired. Foods like quinoa, oats, sweet potatoes, and brown rice provide a steady stream of glucose, keeping your brain energized for hours. Foods that harm brain plasticity. Refined sugar, trans fats, and heavily processed snacks flood your system with inflammatory compounds and oxidative stress, impairing neuron communication and literally shrinking the hippocampus over time. Bottom line, eating for neuroplasticity isn't just about what you add, it's also about what you remove. The fewer toxins and inflammatory foods your brain has to fight, the more energy it can devote to growing stronger and sharper. Chapter 5: Movement and Exercise, the Physical Key to Mental Growth. We often think of the brain and body as separate, but they're deeply connected. One of the most powerful triggers for neuroplasticity has nothing to do with reading or studying, it's physical exercise. When you move your body, you're not just working your muscles. You're increasing blood flow to the brain, delivering oxygen and nutrients, and triggering the release of neurochemicals like BDNF and endorphins, which enhance your brain's ability to grow and adapt. Why exercise is fertilizer for the brain? BDNF is like Miracle-Gro for your neurons. It helps brain cells survive longer, strengthens their connections, and encourages the growth of new ones. Regular movement also improves insulin sensitivity and hormonal balance, two factors that protect against brain aging. Best brain-boosting exercises after 50. Aerobic activity. Brisk walking, cycling, or swimming 30 to 45 minutes, 3 to 5 times per week has been shown to increase hippocampal volume, the part of your brain responsible for memory. Even moderate aerobic activity improves problem solving, attention, and creativity. Strength training. Lifting weights or using resistance bands twice a week isn't just for your muscles, it boosts brain blood flow and supports hormone production. Studies show older adults who do resistance training score higher on cognitive tests than those who stick to cardio alone. Coordination-based activities. Dancing, Tai Chi, and pickleball combine movement with mental challenge, forcing your brain to process complex patterns and timing. This dual stimulation enhances both motor skills and cognitive flexibility. Yoga and mind-body practices. Yoga, Pilates, and mindful stretching reduce stress hormones like cortisol, which in excess can damage the hippocampus. They also improve balance, an often overlooked part of maintaining independence as you age. Pro tip: time your exercise just before a learning session. Studies show that memory retention and mental clarity spike immediately after physical activity, making it the perfect warm-up for any brain-challenging task. Chapter 6: Mental Workouts, Exercises for Your Brain. Just as a gym routine builds muscle, mental training builds brain connections. The secret is to push your brain beyond the comfortable and familiar. Best practices for neuroplastic stimulation. Learn a new skill. Whether it's learning the guitar, mastering a new language, or painting, novelty forces the brain to create new pathways. The greater the challenge, the more rewiring happens. Switch up routines. Use your non-dominant hand to brush your teeth, take a new route to work, or rearrange your kitchen. These small disruptions force the brain to adapt, activating underused areas. Play strategic games. Chess, Sudoku, bridge, or even certain video games engage memory, problem solving, and forward planning, all crucial for keeping your mental agility sharp. Combine physical and cognitive tasks. Activities like learning dance choreography, martial arts, or even juggling merge movement with thinking, which supercharges neuroplastic changes. The sweet spot for brain growth. The challenge must be enough to make you concentrate fully but not so overwhelming that you give up. This optimal difficulty zone is where the most powerful neural rewiring happens. Key takeaway: your brain thrives on novelty, variety, and complexity. The more you step outside your mental comfort zone, the more you keep your mind young. Chapter 7: Stress, Mindfulness, and Emotional Resilience. Stress is not inherently bad. In fact, short bursts of stress, like the kind you feel before giving a speech or solving a challenging puzzle, can actually sharpen your focus and performance. This is called acute stress, and it can be beneficial in small doses. The real threat to your brain comes from chronic stress, the kind that lingers day after day, often without you even noticing how much it's wearing you down. This type of stress keeps your body in a constant state of fight or flight, pumping out high levels of cortisol and adrenaline for far longer than nature intended. Over time, elevated cortisol acts like a slow poison for the brain. It shrinks dendrites, the branching extensions of neurons that help transmit signals. It disrupts the function of the hippocampus, the brain's memory and learning hub. It reduces the production of BDNF, brain-derived neurotrophic factor, the growth factor essential for neuroplasticity. When BDNF levels drop, your brain's ability to adapt, form new connections, and repair itself slows dramatically. But here's the good news: your brain is also incredibly responsive to stress-reducing practices. The most powerful and accessible of these is mindfulness. Mindfulness isn't just about sitting cross-legged in silence. At its core, mindfulness means training your attention to focus fully on the present moment, without judgment, without replaying the past or worrying about the future. Here's how mindfulness helps keep your brain young. It reduces cortisol levels. Studies show that as little as 10 to 15 minutes of daily mindfulness meditation can significantly lower stress hormone production. It strengthens the prefrontal cortex. This is the part of your brain responsible for planning, self-control, and emotional regulation. It improves connectivity. Regular mindfulness practice increases communication between the prefrontal cortex and the amygdala, your emotional response center. This means you react to stress more calmly. Practical ways to build emotional resilience after 50. Mindful breathing. Set a timer for 10 minutes. Inhale for 4 seconds, hold for 2, exhale for 6. Repeat. This calms the nervous system. Body scan meditation. Slowly shift your awareness from the top of your head to your toes, noticing sensations without judgment. Nature immersion. Walking in a park or forest and paying attention to colors, sounds, and scents can reset your stress response. Gratitude journaling. Writing down 3 things you're grateful for each day rewires your brain for positivity and resilience. The takeaway: you can't avoid stress completely, but you can train your brain to handle it better. And when you do, you protect your neuroplasticity. Chapter 8: The Sleep Connection, Repairing and Strengthening the Brain. If exercise is like fertilizer for the brain, sleep is like the repair crew, the essential time when your brain organizes, cleans, and upgrades itself. During sleep, especially deep slow-wave sleep and REM sleep, your brain goes through a series of vital processes. Synaptic pruning. Imagine your brain as a garden. During the day, new branches, connections, grow everywhere. At night, pruning removes the weak or unused connections so the stronger ones can thrive. Memory consolidation. The brain takes your daily experiences and decides what to store in long-term memory and what to discard. This is why good sleep is critical for learning new skills. Toxin clearance. Your brain has a special cleaning system called the glymphatic system that becomes highly active during sleep. It clears away beta-amyloid and tau proteins, toxic buildups linked to Alzheimer's disease. What happens when you don't get enough sleep? Reduced problem-solving ability and creativity. Slower reaction times and weaker focus. Increased risk of cognitive decline and dementia. Lower BDNF production, meaning weaker neuroplasticity. Tips for maximizing brain-friendly sleep after 50. Stick to a consistent bedtime and wake-up time, even on weekends. Dim the lights an hour before bed to signal to your brain that it's time to wind down. Avoid heavy meals, caffeine, and alcohol in the hours before bedtime. Limit blue light exposure. Phones, tablets, and computers trick your brain into thinking it's still daytime. Create a cool, quiet, and dark sleep environment. Around 65 degrees Fahrenheit 18 degrees Celsius is ideal for most people. Pro tip: Pair evening mindfulness or gentle stretching with a consistent bedtime routine. This helps your nervous system shift into rest mode and makes falling asleep easier. Remember, you can eat the perfect diet and do the best mental exercises, but without good sleep, your brain won't fully benefit from them. Chapter 9: Social Interaction and Brain Longevity. We often think of brain exercise as something solitary, reading, puzzles, learning languages. But research shows one of the most powerful forms of brain stimulation is human connection. Why? Social interaction lights up multiple brain regions at the same time. The prefrontal cortex for decision-making. The hippocampus for recalling shared experiences. The limbic system for emotional regulation. Language centers for communication. When you talk, listen, and respond to others, your brain is juggling memory, attention, emotional cues, and language processing all at once. It's like a full mental workout. The science is clear. Older adults with strong social ties have a 70% lower risk of cognitive decline compared to socially isolated individuals. Group activities that involve both conversation and shared problem-solving, like board games, book clubs, or cooking classes, can significantly boost neuroplasticity. Ways to keep your social brain active after 50. Join group activities, dance classes, hiking clubs, or community education courses. Volunteer. Helping others often involves teamwork and problem-solving. Host regular gatherings, dinners, game nights, or themed events. Use technology wisely. Video calls, online discussion groups, and language exchanges can bridge distances. One more benefit: social interaction doesn't just stimulate your brain, it also supports your mental health, lowering depression and anxiety, which in turn keeps neuroplasticity strong. Chapter 10: Building your personal neuroplasticity plan after 50. By now, you've learned that keeping your brain young after 50 is not about finding one miracle activity, it's about combining multiple habits into a lifestyle that supports brain growth and adaptability from all angles. Think of your neuroplasticity plan as a daily blueprint. It should touch on 6 key areas. Nutrition: feed your brain with omega-3s, antioxidants, and slow-release carbs. Movement: include a mix of aerobic, strength, and coordination exercises. Learning: challenge your brain with new skills and problem-solving tasks. Stress management: make mindfulness or relaxation practices part of your routine. Sleep: protect your 7 to 9 hours of high-quality rest like it's medicine. Social engagement: stay connected through meaningful interactions. Example daily neuroplasticity routine for someone over 50. Morning: 20-minute brisk walk plus 10 minutes of language learning or a puzzle. Midday: balanced lunch with leafy greens, fatty fish, and whole grains. Afternoon: social activity, coffee with a friend, volunteering, or a club meeting. Evening: light stretching or yoga, followed by 10 minutes of mindfulness meditation. Bedtime: consistent wind-down routine, no screens an hour before bed. Remember, consistency beats intensity. You don't have to do everything perfectly from day one. Start with 1 or 2 changes, then build your habits layer by layer. The message is simple but powerful: your brain's potential doesn't expire at 50 or ever. With the right environment, stimulation, and care, you can keep it adaptable, resilient, and vibrant for decades to come.